All right, so good afternoon, everybody. Today is February 25th, and we're starting line graph. We're still in statistics. We're doing line graph. So this says the line graph is typically used to display the value of something over time. Time is usually on the horizontal axis and the value on the vertical axis. All right, let's have a look at this question. This says the income received from the sale of its product for the period 2005 to 2010. Sorry. The income a company received from the sale of its product for the period 2005 to 2010. I'm guessing it should have gone on to say, is displayed in the table below. All right. So the income received from the sale, the income a company received from the sale of its product for the period 2005 to 2010 is displayed in the table below. A says using a scale of 2 centimeters to represent 1 year on the horizontal axis and 1 centimeter to represent $10,000 on the vertical axis, we're asked to draw a line graph of the information. All right, so that's not necessarily very difficult. Let's prepare our axes. It's 2 centimeters to 1 year. So 1 centimeter, 2 centimeter. The first year is 2005. So 1 centimeter, 2 centimeter, 06. 1 centimeter, 2 centimeter, 07. 1 centimeter, 2 centimeter, 08. 1 centimeter, 2 centimeter, 09. 1 centimeter, 2 centimeter, 2010. On the vertical axis, so down here is time, and this is in years. Over here is income, and the income is in thousands of dollars. This is in thousands of dollars. It's what is it? 1 centimeters to 10. So this is 10,000, 20, 30. All right, all the way up to 100,000. The first point is 2005 corresponds to $75,000. So 75 would be in the dead middle between 75, 85, and 95. Is that in the dead middle between 70 and 80. Each of these minor divisions is actually $2,000. All right, each of those is $2,000. So we need 75. This is 70, 2, 4, 6. 75 is in the middle between 74 and 76. The next point is 2006 corresponds to 85,000. So that's in the dead middle between 80 and 90. And 2007 corresponds to 95,000. So 95,000 is the dead middle between 90 and 100. All right, so after I have the three of those, the next point is 2008 is 60, then 50, then 65. So 60, then 50, then 65. That's in the dead middle between 70, 60, and 70. Once you have all the points together, you use a ruler to connect them. All right. You use a ruler to connect them. And once you finish with that, what you have is your line graph. This is your line graph. So next, we're going to then use the line graph to answer some questions. The first question is where to state the period during which the income showed the greatest rate of increase. So once you say in a period, it means it's from one time to another time. That's a period. If they said the year, then it would be one particular year. But if they say a period, it means it must be over a period of time. So state the period during which the income showed the greatest rate of increase. So the greatest rate of increase is when you have the steepest slope of the graph going up. All right, and to me, it looks like it's between 2009 and 2010. You could also probably get the information from the table itself. Here, the increase is 10,000, 10,000. And then here, the increase from 2009 to 2010 is 15,000. All right. So the period for the greatest rate of increase would be 2009 to 2010. So to answer that, I would say 2009 to 2010. This is the period This is the period of the greatest rate of increase. All right. Next, we're asked to state the period during which the income showed the greatest rate of decrease. All right, the greatest rate of decrease is when you have the steepest slope going down. That's when you have the greatest rate of decrease. All right. You could think also of rate of gradient. So the steeper the gradient is, the steeper is the rate of decrease. All right, so that would be from 2007 to 2008. That is when you have the steepest decrease, 2007 to 2008. Again, you could get that from the table. 2007 to 2008, the decrease is 35,000. And you have decrease from here, 2008 to 2009 of just 10,000. So the period of the greatest rate of decrease is from 2007 to 2008. So 2007 this is the period of greatest rate of decrease. Next, we're asked to determine the probability that an income probability that in a year that should be chosen at random, the income from sales would be greater than 65,000. So let us see how many times the income has been greater than 65,000. This is 1, 2, 3 times. So the income from sales has been greater than 65,000 3 times. In 2010, it was equal to 65,000. So, but we're not looking at times when it was equal. We're looking at times when it was greater. So the probability that the income would be greater than 65,000 would be equal to 3 times out of 6, or a half, or 0.5, or 50%. So 50% of the time, or there's a 50% chance that if you select a year at random, that the income from sales would be greater than 65,000. Here's the last question. This says, would you expect the sales in the year 2011 to increase or decrease? Justify your answer. So now you're being asked to make a mathematical prediction. Now, based on the information that is available, you're being asked to make a mathematical prediction and then to justify your prediction. So let's get back to the table and the graph. All right, to answer this question, first of all, you have to understand what does an increase mean. In 2010, the income from sales is 65,000. So an increase would mean that the income would become higher than 65,000. If you look on the historical data, what you'd see is that happened 3 times in the past. So we have 3 times for increase. This is based on historical data. And it's only 2 times it decreased. That means it fell below 65,000. So it's 2 times for decrease. So based on historical data, it is more likely that the thing would go up than go down. Because based on historical data, it went above 65,000 2 times and only went below it went above 65,000 3 times and only went below 65,000 2 times. So that's based on historical data. To answer the question, this is what I would say. I would say increase, and this is my reason. My reason is this, that the probability of the income being greater than 65,000, and that probability we already calculated to be 50%, is higher than the income falling below 60,000, below 65,000. And the probability of it falling below 65,000 is 2 times out of 6. 2 times out of 6 is 1/3, which is 33%. So there's a 50% chance that the income is going to be higher than 65,000, and only a 33% chance that the income is going to fall below 65,000. Remember, an increase in 2011 would mean that the income is going higher than 65,000. There's a higher chance, a higher probability of that happening. Therefore, it is based on historical data, it is more likely that the income in 2011 would increase. All right, so example 11. This says the line graph below shows Sabrina's mathematics monthly grades for the period January to June. So it says Sabrina's grades are fluctuating all over the place. She started out with a 52% average, went as high as 81, but the lowest grade she has received has been 50 over the period January to June. We're asked to complete the table. So to complete the table, we have to put in the missing values. In February, Sabrina's grades was 60%. In March, it went up to 81%. So you want to ensure you read these values correctly. And lastly, in June, it was, that looks like 68%. 68%. All right. Now here's what we're asked. Between which two consecutive months was there the largest increase in Sabrina's grades? Just looking at the table, we can see the largest increase was between February and March, when it jumped from 60 to 81. No, here's another one. From, yeah, that was the largest increase, because that increase from February to March, it was a 21% increase. There was an increase in May to June, which is an 18% increase. So the period for the greatest increase is February to March. That's February to March. Then we're asked between which two consecutive months was there. I'm guessing it's going to say the greatest decrease. And looking at this, the greatest decrease is from April to May. So the greatest decrease in our grades, this is from April to May. That's when you have the greatest decrease. What is the probability that in a month selected at random, that Sabrina would get a grade that is at least 70%? So what you want is the probability that the grades, that Sabrina's grades or grade would be greater than or equal to 70%. Remember, at least is an inequality term, and it means greater than or equal to. So let us see how many times Sabrina's grade was greater than 70%. This would have been 1, only 2 times. So it's 2 times, or grade was greater than 70%, 2 times out of a total of 6 times. So the probability is 2 out of 6, or 1/3, or 0.33, or 33%. So there's only a 33% chance that Sabrina's grades would be greater than 70%. We're to calculate Sabrina's average monthly grade. Well, the average or the mean X bar is equal to the sum of X divided by N. All right, that's like from our first class in statistics. When you have raw data like this, it's simply add up the grades divided by the number of values. Add up all the values divided by the number of values to get the average. So her grades, the grades are 52, 60, 81. So it's 52, 60, 81, plus, what is it, 73? 73, 50, 68. 73 plus 50 plus 68. And this is over 6. So let's add this up and see what we get. All right, so when we add this up, we're gonna get 52 plus 60 plus 81 plus 73 plus 50 plus 68. All right, so this is 384 divided by 60. And this is, all right, sorry, it's not divided by 60, what's an error? It's divided by 6. All right, and what we get is 64%. So all this is saying is that Sabrina's average monthly grade is 64%.